So again, we're going to finish the notes, but you're not going to have a lot of time to work on 5-4 during class. The morning class actually is the opposite. They had the whole morning to work on it, but they couldn't finish it because they didn't have the rest of the notes. But I'm going to have yours due at the end of class, which doesn't mean you're just don't do anything all weekend. You have the whole hour and a half to work. It just means that I know you may have questions because you're not going to get much time to work today. Okay, so I'll just make sure you have time to ask and turn it in later. Okay, so we're supposed to use the second derivative test to find the relative extrema. Okay, so again, different test. First derivative test would be first derivative, set it equal to 0, do a sign chart. This is the second derivative test. Now, it doesn't make a lot of sense to do the second derivative test on these type of questions, but we need to use them to learn. Okay, so we understand how it works. Okay, so we still have to find the first derivative because the second derivative test, you're going to plug in the first derivative into the second derivative. And you'll see that because that's going to tell me if it's positive or negative there. That's the idea, okay? So I'm still going to need to find the zeros here. And you'll see as we do the test, it'll just be easier to figure it out, okay? So it'll just be easier to understand as we go through an example. So I still find the critical points because I still need to find out where there could be relative max and mins, right? Critical points are those places where there could be. So I'm going to set this equal to 0. As I do it, I'm going to factor out. So what do I have in common here? 4x squared. So I'm going to be left with x minus 6. So my zeros are 0 and 6. Those are my critical numbers. Okay. Now I need to do the second derivative. Or actually, I don't need to do the second derivative yet. Well, yeah, we need to do the second derivative. Then I'll show you what we're going to do with it. Okay, so the second derivative is
12x squared minus 48x.
Minus 48x. Very good. Okay, so that's the second derivative. Now, don't set it equal to 0. Because what I'm going to do is I'm going to plug in these critical points and find out whether the second derivative is positive or negative there. Okay, so if I plug in 0 to this and this answer on the second derivative is positive, it means the function is concave up there. Which means at 0, I must have a relative minimum. If I plug in the number to g double prime and it's negative, that means that g double prime is concave down right there. So therefore, that place has to be a relative max. Okay, because remember, relative mins and maxes could occur at these two places. So we have to figure it out. Okay, so what we're going to do is we're going to plug in our critical points. And I guess actually that's what she kind of has that table for, but I wouldn't do it that way. So I'm going to plug the critical numbers in. So you may want to write that down, that that's what we're doing. So I'm plugging in the critical numbers to see what happens. What happens at g double prime? 0. Okay, so when it's 0, then I can't make a conclusion at all. Okay, because I don't know, it's not concave up or down there. I don't know the concavity, so I can't answer anything about relative max or min. G double prime of 6, so we plug that in. That's 12 times 36 minus 48 times 6. Now, I know a lot of you want to grab your calculator right now. It's itching. You want to do it, you got to not do it. You got to go to the side and do the arithmetic because you have to know how to do this on the AP test. So I'm going to just do it over here, this bottom corner. So I'm going to do 36 times 12, and you think I'm joking that some of you don't know how to do this, but some of you don't. So you do 36 times 12 on your little paper, and then you can look up here. And then you do your 48 times 6 also. Okay, because half of your test is multiple choice, and 2/3 of your test is without a calculator. So if you want to be able to answer this question, you got to do that. Now, technically, I don't need to. In a minute, you'll see why. Because I really only cared, did it give me positive or negative? So this is far enough right here. I certainly probably can't just glance at that and know for sure. I mean, I probably want to get those two numbers. Make sure I realize it's positive, okay? And you can even write that, greater than 0. So that's what I found, because that's what I care about. Is it positive or negative? So let's think through this whole thing again. So critical points are places where you could have a relative max or min. Second derivative, positive, it's concave up, negative, concave down, 0 is inconclusive. So for this test, for the second derivative test, the answer we have to give for 0 is it's inconclusive. Do not say it's not a max or min. It's inconclusive. This test is inconclusive, okay? But for 6, we're saying at 6, the function g is concave up. And the number 6 is a possible relative max or min. So what is it going to be?
Possible relative min.
It's got to be not possible. It absolutely is a relative min. Because the function is concave up. 6 is a place where it could occur. It's definitely there. It's a relative min. Okay? So my answer would be my conclusions from this test. Okay? There's a local or relative min occurs at x equals 6. And it did say to find the relative extrema. So we probably should say a relative min of negative 437. You hope they don't ask you that. I'm just going to give you the answer. Hopefully they don't normally say what it is when it's that big, right? It's that big of a mess. But that's what it is. It occurs at x equals 6. And what was the reason? And the reason is because g double prime of 6 is greater than 0. And that's our reason. Because I found critical points, I plugged it in, second derivative is positive. At x equals 0, we can make no conclusion. And you could write y for your notes, but you really don't have to say anything. They're not going to ask you that really. Generally, usually it's just that you have to answer the question using this test because that's what you have.
I have a question.
Uh-huh.
When writing like the relative min or max, do you need to say like whatever occurs at, or can you
At,
just say
just at sign. Yep. So it's whatever you say that makes sense to you. Like if some people need to say occurs because it's gonna kind of reminding them that that's where it happens. The X is telling me where it happens. Okay, so let's do this one. So same thing, we're going to look at stuff and we'll kind of use this little table this time just to see. So we're going to look at f prime of x. We've seen this function before. This has been an example that we've done. So we're going to do it a little different, and what's different here is the domain. So for some of you, you probably need to circle domains, you need to mark it, you need to make note, hey, pay attention, whatever. Okay, so what's the first derivative? Right, and again, we've kind of done this one before. The difference is I need to solve when does this equal 0, but my answers are from negative 2 pi to pi. So we got to make sure we get the answers correct here. So this is when is cosine x equal 1/2. So first quadrant, that was pi over 3. We've done this before. So now I have to think to myself, where else would it be? So from 0 to pi, is there another one for cosine? No, because top half of the circle, first quadrant's only where cosine's positive. So now I have to think, okay, now back to negative 2 pi just means take the circle and go backwards. So pi over 3 would be It'd be negative 5 pi over 3, because I have to go backwards around, right? I have to go back around to it. So this would be negative 5 pi over 3. And then we did this problem before, so we know that the other place, if pi over 3 is positive half, 5 pi over 3 is. So how do I say that backwards? Negative pi over 3, right? So those are your places. Okay, now you may have to work on some trig stuff. Some of you are rusty for sure. You still aren't working on your unit circle or anything. So you got to think about all that. Okay, so the C's that we're going to check then, what we're going to do in this table is we're going to check x equals C. We're going to do negative 5 pi over 3, negative pi over 3, and pi over 3. And I don't know why they have f of c there. I guess just you could, I would just do that if I found out that I had to find the max or min, okay? So right now what I want to know is what, if I plug these things into f double prime, do I get positive or negative? Okay, so that means I need to find f double prime. So what is f double prime? Okay, so now I want to know what the value is of all of these things into sine x. So this is kind of like a unit circle exercise. Well, I know that cosine was a half at those three places, so that's kind of an advantage. So I know my answer is square root of 3 over 2, just whether it's positive or negative. So if I'm at negative 5 pi over 3, that means I went this way around and I'm back up here. So I'm actually in quadrant 1, right? So sine will be positive. Do I care what the answer is? Nope. Positive or negative. Okay, if I'm at negative pi over 3, that means I started at 0, but I went backwards. So sine is going to be negative there, right, because it's below. And then positive pi over 3, of course, it's going to be positive because we're in quadrant 1. Okay? Wow, she has this all kinds of wrong. I don't even know what she has written there. Negative pi over 3. Pretty sure sine's negative. Okay. So anyway, what this means is, so I'm not going to go to finding the value, because if I were to find the f value of those places, it's not that hard, because you just would put whatever plus the unit circle thing. So it's not that hard, but I don't want to worry about it. I care more about, is it a relative max or min? Okay. So if I'm at negative 5 pi over 3, so again, I went backwards this way, so I ended up here. So that's why it's positive for sine. So then I need to say to myself, okay, what does that mean? So this is the second derivative was positive. So that means the function is concave up, which is a right side up bowl. So you're going to have a minimum or a maximum there. Minimum. So that means we have a relative min at x equals negative 5 pi over 3. We're not going to find where the other part. At negative pi over 3, we're down in the quadrant 4, right? So it's negative. F double prime was negative there, which means that it's concave down, like an upside down bowl. So I'm going to have a relative max. And then it's positive at pi over 3, which means if the second derivative again is positive, means it's concave up. It's a right side up bowl, so I'm going to have a minimum. And then again, you really should have found the y, but whatever. We're not going to do that today because that's too much time to worry about. Yeah, and then she did all decimal-y stuff and everything on her little key here. And then she wrote the right answers. There were the relative mins, but she wrote positive, negative wrong. So whatever. Okay, so let's look at the next question. All right, so here's again, I would like triple, quadruple star this question because again, probably 80% of the time, 90% of the time, one of your questions, your free response questions, has a graph of a derivative of some kind and then ask you a bunch of questions about it, okay? So the graph of f prime, so you might want to write derivative, okay, or circle f prime or something, but at least remember this is the derivatives graph, okay? So then it says on what open intervals is f increasing or decreasing? So what do I care about on this graph? Above and below. That's all I care about, right? Because this is the derivative, so I care if it's positive or negative. That's it. Okay? Because it's increasing, decreasing. So f is increasing on what intervals?
Negative infinity to A.
Negative infinity to A.
Union B to C.
Union B to C. And then that's it, right? Because that's when the graph is above. So what's my reason? Because, and do not say the graph is above. Don't even say f prime is above. You say because f prime of x greater than 0. Never, ever, 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 ever say it anyway. Like don't say it is above or it is below or it is positive. That's never going to make sense because I don't know which thing you're talking about. Okay, part B. At what values do we have a local minimum or local maximum? So you're going to have a local min or max if f prime changes signs, which means it goes from above to below or below to above. So here you go from positive to negative at A. So A is A, positive to negative, increasing, decreasing, relative max. Okay. B goes from negative to positive, so this is relative min, and C goes positive to negative, relative max. In just a second, we'll write down these answers, or, I mean, all you have to do is say f has a relative max at x equals A and C because f prime changes from positive to negative. And f has a local min at x equals B. Here's a perfect example where we have to give the x values right because we don't know anything about f. We don't have any function to answer. And again, because it changes from negative to positive. Okay, so C says, and it's not on this page, but you can see it at the same time, state the inflection points. Okay? So inflection points mean where the graph of f, not this graph, right? Not this graph, but where f changes from concave up to concave down or vice versa. Okay? So this is f prime. There are two ways to talk about concavity. You can say the second derivative is positive, it's concave up, negative, concave down. But, so let's think, this is that part where we got to really get this in our head. F double prime is positive. What does that mean about f prime? It's increasing because f double prime is this one's derivative, right? It's the derivative of the derivative. And so it doesn't matter what level I'm at. If I look at the derivative of something, wherever I am, fifth derivative, doesn't matter. If it's positive, then the one above, I kind of call it above. Okay, so I think of derivatives as going down, because we're going to do integration later, we're going to think about going up. Okay, so if I'm doing f prime, I look at its derivative, it's positive, that means this one's increasing. So if f double prime's negative, decreasing. If f double prime's positive, f is concave up, negative, concave down. However, I could shortcut and not have to find all of that first, and then say concave up and down, and then say it changes, by simply saying if f prime changes from increasing to decreasing, or decreasing to increasing, then I have an inflection point. Okay? Really important to focus on that on your homework and all your stuff. Because it's the same thing to say it goes from positive to negative as f prime goes increasing, decreasing. And that's a theorem. And that was that. You had two pairs of sentences on one part there on the notes. And that was one of them. One said concave up to down. One said increasing f prime changes. Okay? So f prime is changing right here. It is going decreasing and then changing to increasing. So that means that this point right here, -1, -3, is a point of inflection. Because, and our reason will be, because f prime is changing from decreasing to increasing there. It's easier to answer that way than to have to write all the concavities out and then say that's why it changed, okay? So it's easier for me just to look from a graph, okay? So what's happening at 3, 2? F prime is changing from increasing to decreasing, so therefore this is also point of inflection. And again, your reason will just be because F prime changed from increasing to decreasing there. And you actually could just list both and say that F prime changes from increasing to decreasing or vice versa. Because it doesn't matter which one it does. It's not relative max or min. It's just point of inflection. So you don't have to say this one it does this and that one it does that. Now you do for relative max and min, right? Because I have to say it specifically changed from one to the other to be a relative max. Okay. So that's all we're going to do today. So on Monday, I will probably do example 9. So like I said, do as much as you can of the homework, and then it'll be due at the end of class. So we're not going to have another assignment quite yet.